No. All right, recording, just look, sorry, recording later on. We just did number 9. So this was the original problem for the homework. And what we did is we added root 12 to both sides, subtracted 2 cosine t, and then eventually you get something that looks like that. Again, then you look at your unit circle. This is just for the recording, so we have it all set up there. And that should be pi over 6, is that right? Just looking at your unit circle, that's all we're doing. Okay. What's the one down here? 11 pi over 6. Okay, so the people that were absent the other day, this would be considered find from 0 to 2 pi. So this one, the answer would be pi over 6, 11 pi over 6, done. That's part B though. And on the lecture notes, we said that part B is probably faster to do. Then you jump to part A afterwards. So part A says, give me all the answers in the whole entire planet, world, universe of all time. And so if that's the case, notice the trig function here is going to go on, right? They're going to intersect each other forever and ever and ever. So that is to designate some way to include infinite amount of numbers. So this is what we do, is we say t is equal to pi over 6 plus 2 pi k. And we're going to define k in just a little bit here. We're going to grab the other one. And then we're going to designate, not a where k is an integer. So if you do integer values, all we're just doing a next rotation, because we're just adding 2 pi each time, or subtracting 2 pi if it's a k is equal to a negative. Okay, number 9 is good now. Okay, again, not going to finish them off for you. I want to finish up that one. People that were not here last week. So on these ones, almost always, you're just kind of stuck on some kind of part of the solving process. So once you say, oh, cool, I got it now, thanks, we'll move on here. So let's go 21, 25, 21. So find all radian measurement and then from 0 to 2 pi. So 21. And again, tell me if I'm going too fast. I will be no problem in slowing down, doing it again.
So this one is just negative x equals 0 and then
Yeah, so break it off just like we would break it off like x and x minus 1 in algebra class. Ah, that's interesting.
Or no, I just did it. First tangent squared of x minus tangent x equals 0. Tangent squared of x equals 0. That's 0. Or, yeah, there was one, it would be 1 to 0. So, I got the same answer actually.
Interesting. Okay, so let's go over here because you guys did the homework. I want to follow along with what you guys did here. So in algebra, if you distributed instead of factored, right, you would get this. Because all these guys are going to include. So then if you look at this, you ask yourself, okay, what numbers would work here? But now really what you're doing is you're kind of just guessing, right? You say, hey, 0 is going to work. And then 1's going to work. Negative 1 won't work. So here you're guessing, as opposed to if you were to factor out each one piece here. So there's that one. And there's that one. So you do want to get to each piece. So tangent of x equal to 0. This is a factoring process. Tangent of x minus 1 is equal to 0. And we're just trying to solve this one. So back to unit circle. It's going to happen here and here. True. On this one, it's only going to happen. Oh, no, actually, multiple. Here and here. Pi over 4, 5 pi over 4. In fact, let's finish off this one too, because this will be good to see. So this time the variable is x. For part B, that's easy enough. 0. Don't put a degree symbol because we're in radian measurement. Pi over 4, 5 pi over 4. We good there? That's for part B. Part A. X is equal to, oh, how funny. That's that 0 part over there, right? So it's kind of like 0 plus, yeah, 2 pi k. Oh yeah, that's cool. Look at this. Notice that it's half a circle, half a rotation away. So the easier way, the more compact way of writing it, you could just write it as 0 plus just pi k. Right, because half a rotation can keep on going half rotations. Is the tangent one? Tangent equal to 1, is that also half a rotation? Absolutely. So not 2 pi k, but just pi over 4 plus pi k, where k is an integer. Cool. So another question is, Mr. Engineer, if I wrote down each of them individually, would that still be correct? Absolutely. You needed it and you did it like this here, and it's like a 0. In fact, yeah, 0 plus 2 pi k, pi plus 2 pi k, plus 2 pi k, so pi over 4, 5 pi over 4 plus 2 pi k, no problem whatsoever. Okay. Just designate where k is an integer. Cool. So no wrong way of writing it, just more compact way of just writing half rotations if you have them. Okay, we're good there. Still jamming? Again, tell me to go back if you need for me to go back. 25. 25, 25, 25. Ooh, yeah, 2 sine squared x minus sine x minus 1 equals 0. In fact, if you go back just to algebra, because this is just algebra in a whole new way, how would you guys solve that in algebra class? Absolutely.
Oh, man, I used to love it. Yeah, it's Sine x times 1 and 2 sine x.
So in algebra class, you'd probably dilute this down to a what, -1 here, +1 there. So with trig functions, it's going to be 2 sine of x plus 1. So let me actually do it this way here. So the way you would get a 2 sine squared x is 2 sine times sine. Then we're just trying to get a negative sign in the middle. So that means this has to be a negative to cause this to be a -2 sine x. Positive in order to make a -1 at the end. Okay, set each of them equal to 0 because that's the factoring process.
Oh, that's just minus. I thought it was minus 5.
Okay, good there. So sine of x is equal to a -1/2. Da, da, da. And sine of x is equal to 1. Da, 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 da. And we go from there.
This one would be
25, 25, 25. It is in no radian measurement still.
But it says theta is a degree, and any other letter different. So it's 1 at, it's higher 2 at 1.
Oh yeah, so this one unit circle is pi over 2.
Is this only that? Yeah. Yeah. No. Yeah. But then it's at -1/2, it would be at.
Oh, below the x-axis, right?
110 degrees is really big.
It's, unless I'm wrong, you said how 6 and 11 times.
Yeah.
Okay, you guys finish it off. At that point we did there.
And just do pile plus 2
Perfect. Down. K's and then K's an integer. All right, good there with that one. Let me jump back to what we have here. 41, 45. 41. 41. Now these are called rotational angles.
Oh, I have it.
Okay, well, I think I have the right answer, but I don't think I did it right.
Okay.
One sine is 1/2.
So let's go for it.
Yeah, A equals 0.
Well, it's also 1/2 at 120 degrees.
So let's go with it here. So we are in degree measurement here. And so notice the angle itself actually has a rotation to it. So here we get a 1/2, 30 degrees, and then 150, I believe. Yeah, 150 is the other one.
Oh, I know where I said 120. It is 100. There we go.
Yeah, so by us finding the angles, we didn't solve for A yet. We've solved for the angle
Sine A
measurement.
plus 30.
So I did 30
That
minus
makes-
60 degrees, but I should have 0 and like, you have to do A minus the,
That's what we just found. Go there. So we subtract. Oh, there's 120 right here. Isabel?
Or is that just they're not necessarily the formula?
We're still doing the same thing. The question is this: have we found the sine on one side all by itself? Yeah, because there's nothing being added or subtracted anywhere here, right? So that's all done. So sine is all by itself.
and you just
So
keep
now-
30 degrees in the formula when you're finding angle.
Mhm.
So
So then we do that. We say when is sine of 1/2, 150 and 30, but then we have not solved for A. We've solved for A plus 30. So then got to do a little more work there.
Then I think I'm trying to do 5 and something else with it. But I did the exact same method to get the other one.
Yeah, you guys talk to me. Anybody else need 45? 45 going. Yep, absolutely. This is for you guys here. Okay, so same thing here, a rotational angle. Now this time we are adding pi over 12, which is technically 15 degrees. We're trying to figure out this right here. So do we have the trig function all by itself on one side? Yeah, there's no addition or subtraction to it anymore.
you know it's at 45 variables. 5 pi over 4.
I think so, yep, 5 pi over 4. This way, and then 7 pi over 4. A little bit of work because of common denominators, that's all. So I have two sets of answers here. I have that is for the 5 pi over 4. 7 pi over 4. Yep, so we subtract. We have a common denominator here, so that's 12. So by 3. How about a 15 pi over 12 minus a pi over 12? Oh, how funny. It makes a 14 pi over 12, but then we reduce. So this guy actually becomes 7 pi over 6. Is that right?
Oh, no.
It's fortunate to make it.
Oh yeah, so if we, let's kind of think of this analytically now, real quick here. Guys, so what we have is we have pi over, maybe it helps with degrees here. But pi over 6 is the same thing, pi over 12 is the same thing as 15 degrees, right? So what we did is we figured out that the answer is down here, which is the same thing as what, 225 degrees? And so what we're doing is we're rotating this little answer back an extra 15 degrees. That's what we're doing. And so if that's the case, subtract 15, we get ourselves to 10, right? Because it's just 15 degrees from a 45-degree angle makes a 30-degree angle. Same thing here. So from the 45, we're going to rotate back this way to get us in this position here. And so are we okay now? Multiply by 3, 21 pi over 12 minus pi over 12 makes 20 pi over 12 makes half of that, half of that. There. Yeah, it rotates back 15-degree loop there. Okay, I think we have enough time to finish up stuff here. Okay, guys, are we good there? 6.1 done? All right, finishing up things that you need to here. We're going to go on to 6.2 now. 6.2. The best way to do it is to tell you the objectives for 6.2. So here it is, 6.2 more. How about that? More on trigonometric equations. As if you guys did not have enough.
We heard you like trigonometric equations, so we put the trigonometric equations in your trigonometric equations.
Hopefully 6.3 isn't more and more. I'm sure you could. Okay, so let's see what we have here, the objectives. We can kind of put it together here. Here it is. We're going to use identities.
I just have one question on next year. So there's like whole thing like the classical classes. It's like advanced geometry. Does that count as a math class and your classical credit?
I don't know.
I'm not saying.
But I'm saying it counts for 2 credits. You know, 3, and it's like.
I have not even seen the schedule yet. When did it come out?
Same for physical education, and then classical education, like Latin, Greek, astronomy, advanced geometry, all that other stuff, for example. So I was wondering if advanced geometry would count as your credit and the classical credit. If you don't do
Got it. Yeah, don't know. It's so new. As we're
Honestly, the most.
It's so nice.
I started reading it. I'm like reading it on my phone.
Oh,
so, guys, real quick here. So those are basic problems. Let's see. The basic problems we solve is solve for the trig function, right? Look on the unit circle. The other one was we had to do factoring sometimes, right? And then we just did those rotational stuff. Okay. What's the next add-on stuff? Is using identities. In fact, if we want to, we're going to do like this. I'm going to do one. I'm going to do a problem. You guys get to do a problem. Good. Next is we're going to work with fractions. So we're going to be clearing denominators. That's going to be 3 and 4. Ooh, how about this one? Do you guys remember this from algebra? You guys get good? Remember this from algebra where you had to square both sides of an equation and we had something called extraneous roots. Oh,
I thought I'm going to
we'll try to survive. I don't know, we'll see. But then we're going to use a graphing calculator to solve them because sometimes you just can't. You have to solve here. So let's jam. Let's jam. It won't be that bad. Let's go. So 2 sine theta plus sine 2 theta equals 0.
Oh, that's fine.
So notice you got this little double angle for sine 2 theta.
Well, you can use whatever double angle formula.
Yeah, what is a double angle formula? Oh, cool. Okay. So
I don't remember them. I just looked at formula.
one second, I'm going to do something else real quick here. Real quick. I'm going to use this one here. Okay, so double angle formula for sine. Yes, you do have to have your formula sheets out in front of you. This is the best way to do it here.
You just memorize every single one.
It is set equal to 0, so I'm thinking factoring kind of in my background. Maybe factoring over here. I know I have, hey, this is so cool. Notice there's no part A anymore. It's just from 0 to 360. Notice also it's not 360. So it's like one full rotation, but not getting back to the 360 part. We're good?
So if an answer is 360 degrees, it doesn't count.
So if answer is 360 degrees, you already have the 0 that already got that answer. We're good because the 0 is here, right? So as you rotate it, you get close, but not back to the 0 mark. So you truly have just one full rotation in its entirety by doing that. Okay, so sine of 2 theta. I think it's 2 sine theta cosine theta. Anybody?
Then you can pull 2 sine theta out.
Oh, perfect. Yeah, 2 sine theta. And I'm going to try a few things here. Oh, yeah. Two sine theta out makes 1 plus cosine theta equals 0. That's cool.
Oh, now you just set it to 0.
Oh, perfect. Uh-huh.
So sine theta is 0.
Yeah.
Cosine theta is 1. Oh, and then you just find that's that.
Yeah, then you just say we'll do it at that time. You probably should have been-
No, it's just pi. And then you keep.
Sine of 0 is where?
At pi.
We are in degree measurements.
Oh, so 180. 180.
No, hang on.
Sine of pi is 0.
Yeah, 0, 0 degrees
Cosine has to be 1 too.
and 180 degrees.
Oh, wait, cosine would be 1 to be a 0 degree.
Ooh, hold on, let's see. We take the cosine over.
I
Yes,
thought
we subtract 1 from both sides, we get cosine theta is equal to -1, and what do we have? 180 degrees. 180 degrees is redundant, so final answer, just 0 and 180 degrees would be just fine.
How can it be 0?
The final answer for both. So we have 0 that comes from here,
Oh,
and then we have 180 that's listed twice, so. Cool, not bad, right?
yeah.
I think not bad. Okay, all yours? Maybe all yours? So before we think about this here. Remember cosine 2 theta, double angle formula for cosine has 3 different forms, right? One, two.
Square annoying.
Which form? Which form do you think we should use?
Don't be all cosine ones probably, but I don't know.
I think I agree with Isabel. You guys okay here? Let's go with the one that actually has only cosine inside it. Otherwise, we're going to have to use the sine stuff. Yeah, and this time it's x. So form. So second form is what I want to use. It'll be 2 cosine squared x minus 1 minus cosine x is equal to 2. It's a thingamajig.
You can just factor it out. Maybe just have it, right? It's 2 cosine x plus.
Yeah, we had a sine one in our.
Either way, same.
Oh, hold on, look at this one. This one's a little different. Look at this. If I subtract 2 from both sides, it gets me a -3.
Oh, then you have to do that.
So let's see if we can factor this down using those numbers there.
2 cosine of x minus 3 and cosine of x plus.
Okay. I have 2 cosine of x times cosine of x makes 2 cosine of x squared.
And then minus 3 and
-3 over here. Plus 1 over here. And I think that would work. Absolutely. Let's solve this here. So set each of them equal to 0.
we have one.
3 halves. Equals -1. All right. When does cosine x give you 3 halves? Never, right? So, yep, can't be above 1. It's not in our domain restriction.
And
Uh-huh.
-1 is at here. I don't know, that one.
180.
That's only the 180.
For this problem, what works is x is equal to 180. That's it. That's the only time this works. And again, well, let's see. And can you always plug in the 180 just to check if it works? Absolutely. If we're to plug it in, cosine of 2 times 180 is 360. So be 1. So we can always plug in answers just to sort of see if they work. Minus cosine of 180. Is that equal to 2? That's cosine of 360. Minus cosine of 180. That means this is what, 1 subtract a -1. That's the only time that it would work because you need to be subtracting off of a -1. to get yourself a 2. So yeah, there's only one answer here. Can't do another answer. Okay, guys, that's it right here. This is the one using some kind of identity that we've known before. Good. Next one. Sorry, let me go back. All right. So this one will be clearing denominators now. So now we're going to have fractions on our hands. And how do we deal with fractions here?
Not what you want.
Yeah, so let's see, I'm going to do that first. So I got a cosecant theta is equal to 2 over root 2.
Except this is for sun.
Absolutely. So isn't this 1 over sine theta? So for these guys, I just want to take the reciprocal. And real quickly here, let's see. How do I do this here? You guys talk to me here. Just back to algebra. Let's kind of think back to algebra. If I have 1 over x is equal to 1/4, let's say, right? Let's say it's that. Could I say like, oh, that's easy because x is equal to 4. Okay, that works for proportions. Now let's work the other way here. If this was a 3, actually, no, I should write like this. If x is equal to, or 1 of x equal to 3/4, am I pretty sure that the answer is 4/3? So all we're going to do to flip things over, we can just flip it over just like that. All right, we take the reciprocal of both sides. We have ourselves a trig function. Which same thing as 1 over root 2.
No, sine is y. It's 45 degrees.
Oh, yeah,
Y. Yeah.
Theta is equal to 45 degrees, 135 degrees. Okay, are we good there? Not bad, right? Not bad. Just kind of getting a little more. All right, how about a trig function and another trig function? So that one, number 3, was a pretty easy one. Good, because it had just had one trig function inside it. This one has 2 trig functions. So this one's a little more complicated here. Let's do the same thing though here. So nothing to flip here. We do have the sine on one side and cosecant on the other. So that's not cool, but I know this is true. Absolutely here. So that one was an easy one because you take a reciprocal of both sides because you had only one variable. This one, we're going to multiply both sides by sine theta. Only other thing, guys, to keep in mind real quickly here is this right here. Let's do this here just to make sure we got it. We're going to say to ourselves this right here. Sine theta cannot equal 0. Good there? Let's see. Let's make sure that we understand this. So when does sine theta equal 0? Okay, see if this makes sense.
Just started thinking in radians, like the first time this year. Now we're doing.
Oh, sorry. Let's go radians. But it's a theta, but it's in radians.
5 or 3.
No. 0 and pi. Okay, guys, real quick here. If we get 0 and pi for our final answer, we can't accept those because that did not work in the first place. Okay, now let's go ahead and actually do the work here. So we're going to multiply So one way is just to take a reciprocal if you're ready for it. The other one is multiply both sides by our common denominator in this case. So 2 sine squared theta minus sine theta is equal to 1. Yep, and I think we've seen this before though. Sine theta plus 1, All right, almost there. Let's see, minus 1 divided by 2. This is just a plus 1. In terms of radian measurement here, what would be the answers?
It'd be a 7 pi.
It was what?
If it's 7 pi over 61.
Oh, you can go to this.
No, no, no. Yeah, 7 pi over 61.
So going over here, you're at pi, right? And just a little bit more. So yep, 7 pi over 6. And then you're just a little bit shy of 360 degrees or 2 pi. So 11 pi over 6 for that one. Sine of 1. That is a pi over 2. Okay, we're good there.
I was really going to do 7 minus 6 degrees.
That's 210. 11 pi over 6 is 330. And then pi is 2.
Okay. How are you guys doing? Good. I'll tell you, grab. Good. Annette, okay with that? Okay. So this is dealing with fractions here. So next, dealing with 2 trig functions at the same time.
Oh.
So I have a sine and I also have cosine at the same time. That's our problem. Let's see, the only connection I know between sine and cosine. What do you mean by tangent? I'm not going to go that direction here. Let's see. We have the Pythagorean theorem to deal with, right? So if I can get this to be a sine squared or a cosine squared, either one, then I could use the Pythagorean theorem to give me the other one.
Just square both sides.
There you go. I'd go with that. Okay, be careful, super careful here, guys. If you square both sides, you get something called, or might get something called extraneous roots. Extraneous roots. We didn't cover that too much in algebra. But here's our little problem right here. You guys, real quick here, tell me if you guys agree. 5 equals 5. If I were to square both sides, and it only works on squaring. If I were to square both sides, is this still true? Yeah, that checks out. That's cool. But is this true? Nah. But if I were to square both sides, is that true? So here's our little problem. When you square things, it doesn't matter if you take it to 3rd power, 5th power, 7th power, 9th power, doesn't matter. It's the even powers that is a problem. Because the negative drops off. So it could be that they were actually not even answers in the first place. And they'll always be off by a negative and a positive. We're good? So what do we have to do with extraneous roots? No other way around it, guys. We're going to get some answers. We're going to plug it back into the original problem to see if they are true or not. That's it. That's the way we're going to have to do it. Once you square both sides of the equation, once you're the one that's doing the squaring. Okay, can you guys help me out here though? If we were to square both sides here, We're gonna get ourselves, I think we're gonna get ourselves this. Uh-huh. Oh, plus cosine squared?
We have 1 minus 2 sine x. So sine x. Oh, that's the sine. That's the sine x. Wait. Sine squared x is cosine squared x.
Yeah, we got this. Oh man, look at this. We have that right there. That's not cool. Because now I have two. I didn't get rid of anything.
That's sine of 2. You have to put it back.
That is just no fun. We are done. We are done. Okay. No, we're okay. Are we stuck? I think we got this sine x cosine x problem. Okay, so now the question is this: how can I square it so I don't get this little sine x cosine x thing?
Opposite.
Subtract the 2 sine of x, cosine x. Or I just have to add it in this case to both sides. We'll just do sine squared x plus cosine squared x
Okay.
is 1.
I like Dylan's idea. All right, if we do this here right quick, do we get rid of this little middle section? If we, before we start squaring stuff, so we made you guys do it the wrong way, but you guys will like me for it, hopefully. What we're going to do first is we're going to have to put one trig function on one side, the other trig function on the other side. Therefore, we won't be squaring an x and a cosine and a sine at the same time. So now, so there's that, and there is that. Boom. Okay, now if I square it, perfect. I am not going to get this little weird. Now let's see. Yeah, we're going to have to battle with root 2, but let's see if this helps us here. So this is sine squared x. That's cool. This one's going to be a 2 plus. Let's see if I were to multiply. What's the middle term going to give me?
Plus 2.
Okay, so we do have to battle with the 2 root 2. Okay, let's see how that works out. Everybody okay with the 2 root 2 in the middle? All right, it's the root 2 and the cosine multiply together and then doubled. Okay, I think I know which one I'm going to use because this is a cosine to the 1 power, so this will be 1 minus cosine squared x. I see a cosine squared, I see a cosine, so I know I'm factoring here. So let's move everything into factoring position. I'm going to add cosine squared x to both sides. Just kind of still have the 1 here, so I have this guy here. Deal with there. And what do I have? Subtract 1 from both sides, I get a plus 1 then. Is that what I have? Not good, not good. Subtract, yeah, subtract 1 from here and subtract 1 from here. This looks so much worse. Now, the reason why it works, the reason why it does not look very nice is because we had a square root of 2 in the first place. If it was just a 1 or a 2, this would be no problem, right? Just multiply together. It's that little square root of 2 that's our problem. Okay, so let's do this. I guess the only thing I can't, like, we don't know how to factor roots of 2. We're good. We don't do that. When we do the factoring process, it's only integer values and sometimes fractions. For the most part, integer values. There it is, okay. Quadratic formula in this case. Okay, so this was the tough one. On the homework, you are gonna get like a 1 on the homework, I believe. So it's gonna be way easier.
Two is not bad now.
So 2√2 plus or minus the square root of 8 minus. Is that right?
Oh, it's negative 2, right? Negative 8 plus minus 2.
Oh, thank you.
And that's just 8 minus 8.
Yeah, this whole discriminant goes away. That's cool. This is a 4. So that means we're looking at when does cosine of x give us, let me go back over here for it. Cosine of x? Is that what we're dealing with? Yeah. So negative 2√2 over.
So,
225.
negative x.
Oh, no,
225
225.
and 139.
In radian measure.
That's going to be 5 pi over 4.
5 over 4 and
3 pi.
awesome. Quick question. Did we square both sides of the equation?
Yeah.
Oh, shoot. We squared both sides of an equation. Go back and let's check this out. So does 5 pi over 4, does it work for the original problem? Yeah, there should be easy angles here. So the question is, does this work? Is that true or false? Sine of 5 pi over 4, help me out here. Uh-huh. Yeah, we do have to check the other one here. Let's see. Is it going to work? Let me just check here.
Because that's going to be root 2 minus negative root 3. It's just going to be plus root 2. Yeah, that makes sense. It's like 1/2 plus 1/2. It's going to be root 2 minus negative root 3. Root 2 plus root 2, which is like 1/2 plus 1/2.
Okay, so final answer here. 3 pi over 4. Happy to reject. That is there. Okay, that is called squaring both sides of an equation. Right? We had to get rid of that little, and we have to set them up so that we move the trig functions over to each side. I know, shucks, right? Because then the homework is afterwards. Ooh. Oh, half angle formulas. Yeah, we'll have to look those up now.
Plus or minus 1 minus cosine A.
Wow. Well, off to the side, let me talk about this here. Let's see. So sine of theta over 2 is, there's a plus or minus in here, huh? Is it 1 plus cosine? Minus, okay. And is the 2 inside the square root, is that right? Boy, that's definitely gonna be a square root on that side. So here it is. Do we have the trig functions on each side separated?
Oh, we should need to
Not
subtract.
I'm gonna subtract, yeah. So let's subtract that first, just to kind of get it over to the other side.
We can do square.
Oh, wait,
Substitute, is that right?
it has cosine in it. It's not sine anymore, so it's actually,
We still have square.
We still have the square root thing because we still have that square root to undo. So that's the reason why we square this time. So 1 minus cosine theta over 2. All right, 1 minus 2 cosine theta plus cosine squared theta. Let's see, multiply everything by 2, is that right? 2 minus 4 cosine theta plus 2 cosine squared theta. And then set equal to 0. Let's see what we can do here. I'm going to write the 2 cosine squared first. Minus 3 cosine theta. See if that's right. Plus 1, right?
Yeah, it's just 2 cosine theta minus 1 cosine theta.
Perfect.
So there's 16.
Theta. Sorry, going back a little bit because I don't have the answers here. So this is minus 1, minus 1. Is that right? Make that happen? Mhm. Mhm. Cosine equal to 1/2. Good, good.
why is it the one minus cosine theta on the other side of the equation?
We just put it all on the inside. So we added cosine and we exactly one.
Okay. Cosine is equal to 1/2 here. Degrees or radians, that's what I need to know. Okay.
And the negative 60 or greater?
Mhm. We have radian measurement in hands though.
Pi over 6, pi over 3, then
5/3.
and 5.
Third of a pi away from 2 pi. There's that one. All right, just try this. Theta is equal to cosine of 1.
You have to plug them back.
This one's a
It's not
just 0. I don't put a degree symbol because you put a degree symbol in degrees, right? It's just a 0. And guess what we have to do?
Plug them all back.
Okay, real quick here, so we can go a little faster here. Abe and Isabel, check pi over 3.
What's the original?
Oh, original. Annette and Max, check 5 pi over 3. And Tristan and Dylan, please check 0. Yep.
Yeah, sorry. Because I want
Yes, it was.
Over 3, 5 pi over 3.
Because the sine of 30 degrees is 1/2, and cosine of 60 degrees is 1/2.
So just coming back here, here's where we finished, and these guys are checking which one works here. So plug it back into the original, see which one works here. I'm thinking, let's. No problem. Okay, so what are we doing here? We are looking at graphs, right? If you think about it, sine of theta over 2 plus cosine theta, that's a graph, isn't it? And then 1 is technically a graph, isn't it? So we're just saying, when are these two graphs hitting each other? That's technically what we're doing. Okay, so you guys talk to me here. Does 0 work? 0 does not work. Talk to me here. Sine of 0 divided by 2 is still 0, plus cosine of 0. Does that equal 1? Yes or no? I think so. Dylan and Tristan, are we good now? Got you. Okay. No problem. No problem. That's over here. Abe and Isabel, yes or no?
Yes.
Okay, so 0 works. Pi over 3 works, and Annette and Max. That was a toughie, huh? That was a toughie. It's sine of pi, 5 pi over 3 divided by 2, plus cosine of 5 pi over 3, and the question is equal 1. This is sine of 5 pi over 6. That is sine of 150 degrees. Is that right? It's on its way up to 180, but not quite. So this guy's going to be a positive 1/2. Cosine of 5 pi over 3. So I got this one here. That's 5 pi over 3. Next one is 5 pi over 3 is down here. It's a quadrant 4. This guy is a positive 1/2. Is that right? Negative root 3 over 2. Hey, yo, that is so cool. Look at that. Cool. All of them work here. Two minutes to go. Let's jam. Find all the degree solutions from 0 to 360. Round if necessary, and use your graphing calculator. That's some crazy stuff over here. Gee whiz. That one is a pretty tough one. Notice you have cotangent. Notice you have cosecant. Oh, brother.
What? Yeah, okay, so hang on.
Of course, there's not going to be the nice one, right? It's going to be the crazy one, which is good because we got to the point we can't solve it by algebra. Those other ones we can solve by algebra. So you're writing it down and then move out of your way. So y equals, let's see what we can do here. Cotangent, everybody okay with this one? 13 divided by tangent. Would that work? Plus 11, what, divided by what? Mm-hmm. 11 over sine is good by me. So that's one side of the equation, right? That's one side. The other side is 6 times sine of x. That's the other side. And we want to see whether they intersect each other. That's it. So first things first, we're degrees and radians. We're in degrees this time, huh? That's crazy. We might just finish up this one later here. We'll see. Degrees. Are we okay with degrees? Now the little problem is window. In fact, no, let's go to zoom. And look at that. You have a zoom trig button on your hands. At least that kind of starts off the window for us. Let's see. 7. Say again. Doesn't show very well, huh? Whoa. I think we're just gonna have to finish this one later. So you guys can do all the ones except for the calculator questions, which is, you can do up to 32. 33, 35 is a calculator. Sure, absolutely, guys. Totally enjoy teaching you guys. You guys have a great day. What did you get? Oh yeah, fun stuff. That is so cool. We should do abstract art.
Yeah, thank you, Mr. Manager.
Oh,
Hey.
Happy Friday.
Oh, absolutely.
I feel like that's something, you have to say to a math teacher.
Oh, yeah, yeah.
Right?
Thank you, Max.
I write my dates the other way around. So
The trig-
Oh,
the trig students brought, sorry, not trig, sorry, the calc students.
Yes.
brought pies.
fun.
So we had pie early in the morning for breakfast.
I
So
mean,
we were jamming today.
there you go. Isabel, how many inches of hair did you just get cut off?
I know.
I mean,
Like
my hair
10?
here, so a lot.
That is a lot.
Yeah.
Do you like feel lighter? Like you just bouncing your
Yeah.
step?
I'm so used to it being long, like I didn't even feel it anymore, so I simply don't feel the weight of my hair
Wow.
either now.
Did
so-
you donate your hair or
I
no?
couldn't
Yeah.
because
It wasn't long enough. They require like a lot in order to.
most things
donate.
do say 10 inches.
Yeah.
Some stuff is 8, but I had enough split ends that
Uh-huh.
it wasn't enough.
Yeah.
Uh-huh.
Because my hair was cut off.
Yeah.
So,
Mhm.
so no,
Got it.
there was enough hair on the floor, like small, like stuffed animal.
Oh, yes.
Yeah, yeah.
Great. Good stuff.
My sister volunteered the rat.